Hi, this is Alex from devstories.eu. BMad Method, Episode 6 of 15. If you assign two AI agents to build two different features without a shared architecture document, they will inevitably declare war on each other's code. They will make conflicting technical choices that break your application. The mechanism to stop this is Phase 3 solutioning, specifically focusing on preventing agent conflicts with architecture. Humans working on a software project talk to each other. They share assumptions over coffee or through chat messages. AI agents operating in parallel do not have a shared consciousness. They operate in completely isolated context windows. Give Agent A the task of implementing a user dashboard, and it might decide a REST API and Redux fit best. Give Agent B the task of building a user settings page, and it might independently decide to spin up GraphQL and Zustand. When those two features try to merge into the main branch, you face a massive integration problem. Both agents did exactly what you asked, but their isolated optimizations created systemic chaos. Developers often want to skip formal architecture documentation because it feels like corporate overhead. If you're hacking together a tiny isolated script, that is acceptable. The BMad method includes a quick flow specifically for small tasks that deliberately bypasses this phase. But for complex projects, skipping the architecture phase guarantees agent drift. You cannot rely on the default behavior of large language models to accidentally align on the same technical stack across different sessions. To enforce technical alignment, the method uses a specific workflow called BMad Create Architecture. You execute this workflow before a single line of application code is written. It analyzes your project requirements and generates architecture decision records. Architecture decision records are lightweight, structured text files. They capture the definitive technical choices for the project. One record dictates the state management library. Another specifies the exact pattern for data fetching. A third defines the testing framework. They establish the hard, unbending rules of the system. Here's the key insight. In traditional software engineering, architecture decision records are primarily a historical log to help new human developers understand past choices. In a multi-agent AI system, it is an active control mechanism. Large language models have no memory of what another model decided unless you explicitly feed that information into their prompt context. When you run the architecture workflow, the resulting documents are saved directly into your project repository. Later, when you deploy Agent A to build the dashboard and Agent B to build the settings, the system feeds these exact same decision records to both agents before they start writing code. The architectural files act as the ultimate ground truth. Agent A reads the record dictating Redux and REST and builds accordingly. Agent B reads the exact same record and also builds with Redux and REST. The architectural boundaries force independent models to act as a cohesive team. By removing the burden of choice during the feature implementation phase, you drastically reduce hallucinations and prevent conflicting dependencies. Architecture documents in an AI workflow are not just passive notes for humans, they are programmable constraints that force non-deterministic agents to build a deterministic system. That's all for this one. Thanks for listening, and keep building.